Okay, this is the example on equations that involve surds or roots, square roots specifically. And the most important thing that you have to remember here, aside from the manipulation and the calculations, is that you absolutely need to test your answer, right? Because 9 times out of 10, one of your answers are not applicable and you have to exclude it. So how do we solve this? We do it in 3 steps. First step is to isolate, right? Isolate what? Of course, we want to isolate the root. Okay, we want to get him alone. The second step would be to eliminate it. Alright. And then the final step, for the sake of rhyming, is to equate, which is pretty much just solving. Alright. So we isolate, we eliminate, and then we equate. So let's get straight into it. If we have root x plus 3 minus x is equal to 1, we need to isolate the surd, alright, meaning that that x here needs to go. So we're left with root x plus 3 is equal to 1 plus x. Now I always like my variables to be in front. It just makes more sense to me. So we go x plus 1 instead of 1 plus x. Okay. Then we eliminate. Now to eliminate a surd, there's only one way, right? To get rid of a square root, you have to square it. So I'm going to square both sides and I will add that step in. So we go root x plus 3. We square that is equal to x plus 1 and we square that, right? At this point, the exponent over here will cancel out the root so that on the left we're left with x plus 3, okay? And on the right hand side, we have this x plus 1 squared. Now, to save yourself the trouble of rewriting steps, you can perform calculations on the side for yourself in pencil. So instead of having lots of steps, you can do it over here, all right? To find that we get x squared plus x plus another x and plus 1, so that this becomes x squared plus 2x plus 1. So then we take what we got in green and we write it on its place here on the right hand side. Okay, so we go x squared plus 2x plus 1. Right? Now, it doesn't really matter if your answers are on the left or on the right, but because the majority of my variables is on the right, I'm just going to leave it on the right so that we get 0 is equal to x squared plus 2x plus 1, right? Then this becomes negative x minus 3. We go ahead and we simplify this down to x squared plus x minus 2, and this is what we factorize, right? So the factors of 2 that will produce positive 1 is x plus 2 and x minus 1, right? Almost there. So our two answers is when x is equal to minus 2 or when x is equal to 1. So that concludes the solving portion of the sum, but we still need to go ahead and test. So now we do the very last step, which you'll see I wrote down at the bottom. This you can simply do on your calculator, okay? Our first solution was that x is equal to minus 2. So you go ahead on your calculator, you type minus 2 where you see x. So we go minus 2 plus 3, the root of that, minus 2, we get minus 1. But on the right-hand side of our equation, if you look up here, it's 1, meaning that this solution here is not applicable because it doesn't work, all right? So underneath this, you would write NA, not applicable, or you could even just scratch it out. And then for x is equal to 1, when we substitute 1, we get 2 minus 1, which is 1. And we see that these two values are aligned. The left-hand side is equal to the right-hand side, meaning that the final answer and the only answer here is when x is equal to 1. So a brief recap. For surd equations, we do it in 3 steps. We isolate the surd. Anything that is not the square root needs to go to the right-hand side. Okay. Thereafter, you eliminate your surd by squaring both sides. We did that. After this, you just solve it. All right. In this case, we had a quadratic trinomial, and the options here for a quadratic trinomial is to factorize or to use a root or to even use the equation. But factorization worked for us. Then we got our answers of 2 and 1, but 2 did not work, and so the only answer and the final answer is 1.